Alright, so this is our double displacement video. You still need your foldable, you still need your predicting product sheet, your resource sheet, and you still need this monster packet at your disposal. So, the double displacement is a reaction in which two compounds, they specifically have to be compounds. That's not how you spell compounds. Oopsies. In which two compounds react and exchange like parts. Those like parts are typically elements, but they can be polyatomics too. So polyatomic ions, etc. And then they react to create two new compounds. So, let's look at this. Let's say that I need 3 colors this time. Oh goodness. We will do pink and purple and blue, and I need a red. Sure. Or green. How about green? Green. Okay, so let's say we have compound AB. And we're going to react compound AB with compound CB, or CD, there we go. Now the important thing here is these always have to be aqueous. If these are not aqueous, the reaction wouldn't happen. So these two are going to always be aqueous. Two aqueous compounds. When I react them, we exchange ions. So the A and the C are positives, the B and the D are negatives. So remember, we're forming ionic compounds. We need a positive thing with a negative thing. So I'm going to switch places with these two. So therefore, we end up with compound AD plus compound CB. So they just switched places. So A's are positive, C's are positive, D's are negative, B's are negative. One of these has to be a solid. One of them has to be a solid. If both products are aqueous, oh wow, then no reaction occurred. Now think about this. If I have, let me draw this on the board beneath us. If I have A and B floating around in a beaker, what I really have is compound A floating around, or ion A floating around, and ion B floating around. Because remember, when ions are dissolved in water, they're just dissociated. And then I have ion C floating around, and I have ion D floating around. If I never have a solid formed, then no reaction actually happened. If both products are aqueous at the end, it still looks exactly like this. So I need one of them to go ahead and produce a solid, because if one of them makes a solid, let's say AD makes a solid, then I will have A and D together, just floating, like sitting at the bottom of the beaker, like that. And then I'll have B floating around, the B ion floating around, and I'll have the C ion floating around. But if AD was aqueous, then it would really still be dissociated and no reaction would happen. So a solid has to form in order for it to actually change. If a solid is not formed, then no change occurred, no reaction occurred. So you might be asking, how do I know if a solid was formed? I don't know how to figure out the state of matter of compounds yet. Well, we will help you with that. So what you're going to have to do to figure out if a solid formed, you're going to have to check your solubility rules. to determine if a solid formed. That's why you look at your solubility rules to see, will one of these products be solid? And if both products are aqueous, then you do the same thing as you did for the single replacement, where you wrote no reaction instead of writing out the products. So let's go through and let's do our demo. I'm going to do my demo after I write down the example, actually. So let's say that we have lead nitrate. So lead nitrate is lead 2 nitrate, PbNO3 That is aqueous. And I'm going to react the lead 2 nitrate with potassium iodide. And the potassium iodide is also aqueous. When I react both of these guys together, I'm going to get lead with iodine. So Pb plus 2 with I minus 1. Therefore, I get PbI2. Remember to cancel out your charges to make sure that you get the correct formula. So potassium is going to bond with nitrate, plus 1 and minus 1. So I have K and NO3. Then I need to make sure it is balanced. I need 2 of these guys, and I need 2 of those guys. This is balanced. So let's check our state of matter here. The way you're going to do that is you're going to look at your resource sheet. There are 2 ways to do this. You probably will end up using this one more often and this one as a backup. So let's explain this one first. So I need to find lead iodide and see what the state of matter is. So I'm going to look for lead. And it's lead plus 2. So on this sheet, I only have, nope, that's lead plus 2. Lead plus 2, and you're comparing it with chloride. So lead plus 2 and chloride, tracking them down together. Ooh, look, that's an S. That means that lead chloride is solid. The other way I could have checked that is by looking at that's iodide. Oh my goodness. Okay, let's actually check the correct thing first time. So lead and iodide, which is still a solid, so I didn't mess up too bad, but make sure you use the actual correct ions. That would be good. If it was one of these blank spots in here, or if it had this dashy mark there, then I couldn't use this chart and I would have to use this one instead. So the way you do this is you look for the ion. In this case, we have iodide, and you're checking the rules. Soluble means that it's dissolvable. Soluble means aqueous. Soluble equals aqueous. Insoluble equals solid. So iodides are soluble except with silver, mercury, or lead. Now we are one of these exceptions because we have lead iodide. That means that lead iodide is not soluble, also insoluble, which would be a solid. So you can either use this chart or you can use this one to come out with the same answer. So let's look at potassium nitrate, KNO3. So I'm going to use, let's use this one. Nitrates are always soluble with no exceptions. So that would give us potassium nitrate has to be aqueous. Let's double check with the other chart just in case people like that one better. So I'm going to look at potassium and nitrate. That is aqueous. Oh look, they could also check this too. Potassium is always soluble, none. So you can check either way. There can sometimes be multiple ways to come up to the same answer, but you do need to use your solubility rules. Either chart is good there. So this is aqueous. So one of our products is a solid. That means this reaction actually happened. Woohoo! So when you do this, we call it a happy dance because it's like 2 people going out on a date, like 2 groups of people going on a date. You went out on a like group date, Susie and Johnny and Libby and Brad. And so now instead of Susie and Johnny staying together and Libby and Brad staying together, Susie's going to go out with Brad and Libby's going to go out with Johnny. So you swapped dates. So that's why it's a happy dance, because nobody ends up sad and alone. But I think it's kind of weird, because at what point are you ever going to be dating and then just switch boyfriends with somebody else? That's bizarre. So let's do a demo of this. I have 2 chemicals. I have the orange potassium dichromate. Get out of here. I don't want you. Okay, moving up. Why isn't this going away? Oh God, it doesn't matter. Okay, I have the orange potassium dichromate, and I have the clear lead nitrate. So let's go ahead and use another test tube for this. I'm going to be pouring some of this lead nitrate into my test tube and not getting any on myself. So if this reaction happens, we should see a solid formed once we put them together. Okay, let's see what happens. Okay. Do you see how it got all milky? This is not a very clean test tube, but do you see how it got all milky down there? So that powderiness tells us that a reaction actually did occur. You can see the powdery milkiness in here. So that means that a solid was created, and that solid is our lead iodide. Leads tend to be this bright yellow color, but that's where that came from. Okay, so you've now seen your demo. You have now completed your foldable. We are going to be doing a lab on Tuesday, Wednesday to test double displacement reactions and those solubility rules. But at this point, I would like you to go through and I want you to finish this worksheet. So finish this section and finish the rest. You have to finish the whole thing. The answer key is around somewhere. When you are finished with that, if you finish early, you can go through this packet and you can identify the types of reactions of everything. So your homework is to make sure that this is complete, and then if you have time, you should be doing your types of reactions practice, which is just right here. If you still need work on balancing, go ahead and do that as well, but everybody should be doing something the whole class period.